All right, let's talk through these two problems. Number one, first thing I need to do is use long division to rewrite this into transformation form. So x minus 3 goes on the outside. Negative 4x plus 5 goes underneath. What will be my whole number? What goes up on top? Negative 4. Then I take that negative 4, I distribute it to both of the pieces here. This, of course, is my k value. That's my whole number. When I distribute, I get negative 4x and a positive 12. Flip both signs, so this becomes a positive 4x and a negative 12. So my 4x's cancel. What do I have remaining then?
Negative 7.
Negative 7. Okay, I'm ready to write it in transformation form then. So I would have g of x equals what?
Negative 7 over x minus 3 minus 4.
Negative 7 over x minus 3 minus 4. Remember that first number that we write down, that's our whole number. That's k. That's not part of the fraction. What we find after we distribute, flip the signs, and combine, that's our a value. That's our remainder. That still is part of the fraction. Denominator stays the same throughout. All right, part B, identifying the transformations from the parent function. Okay, so I see a here. I see k here. And I know this is going to be tricky, but here's the opposite. So what is a doing to the graph of the function? I heard reflects. And does it stretch or does it compress? Stretches. Okay, so reflect over what? Reflect over x-axis. Vertical stretch by 7. Does A do anything else to my graph? No. What's A doing to my graph? What is A doing to my graph? Or sorry, H. We just did A. H is going right. Going right how much?
3.
Right, 3. And down 4. So let's name our vertical and horizontal asymptotes. Since they said vertical first, let's name our vertical first. Vertical asymptote, x equals 3. Nicely done. And that means that our horizontal asymptote would be what? Y equals how much? Negative 4. I just didn't hear the negative part. You're absolutely correct. Beautiful. Beautiful, beautiful. Let's go to number 2. Number 2, first thing they want me to do is to factor all of f of x. And I did give you guys a hint that that numerator factors along with the denominator. And I told you to look for something first. You should always be looking for this first. GCF. What's in front of the x? Negative. So what could I take out of that? I can take a negative 1 out of both pieces. So I'm going to divide both of these by negative 1. So when I go to factor that numerator, I bring negative 1 out to the front. What would I have remaining after I take a negative 1 out of each piece? X minus 1, yes. If you want to check to see if you've pulled your GCF out correctly, distribute, and it should get you right back to where you were. All right, and then I need to factor the denominator. Does the denominator have a GCF? No. So up on the top, we had a GCF of negative 1. Down on the bottom, there is no GCF. So I know I'm going to need to make my x. Will I be allowed to use the shortcut on this? No. Okay. When I multiply A and C together, what do I get? Negative 15. My B value? What two numbers multiply to negative 15 but add to 2? 5 and negative 3. 5 and 3 multiply to 15. Since my B value is a positive number, I knew the bigger number had to be positive. All right, I'm going to come over here and I'm going to draw my area model, because I got a little bit of room right here. A goes here, C goes here. So 3x squared, negative 5. The two numbers that I found were 5x and negative 3x. What can I take out of these top two, 3x squared and 5x? X. What about down along the bottom, negative 3x and negative 5? Negative 1. So there's one of my factors for my denominator, x minus 1. What about vertically, what can I take out?
3x.
3x. And what about here?
5.
Positive or negative 5?
Positive.
Positive 5. All right, so I've rewritten my numerator. I've rewritten my denominator. Do you guys see anything that will cancel?
X minus 1.
X minus 1s are going to cancel. So what that means is that when I factor f of x and I reduce it, what do I have left? Negative 1 over 3x plus 5 is absolutely correct.
And we know where the x-axis of the whole is.
We know where the x part of the whole is. Where is it?
1.
1. So where x minus 1 equals 0, so I would add 1 to both sides to get the x part of the ordered pair. How do I find the y part of the ordered pair? Substitute it in. All the way back into the original? No, if I put it in the original, I'm going to get 0 over 0. That doesn't help me find anything. So what do I sub it into? Yes, this part right here. After I canceled it out, I'm going to sub it into what's left over. So I would have y equals negative 1 over 3 times the x that we have is 1 plus 5. So negative 1 over 3 plus 5. What's 3 plus 5? 8. That is the y part of the ordered pair for the whole. So whole at 1, negative 1, 8. We're going to practice graphing those types of things today. All right, just vertical and horizontal asymptotes. Our vertical asymptote is a little bit tricky this time. Why? Yeah, when I look down at the denominator here, normally we just flip our sign, right? It's just the opposite. Does anybody remember how we actually get it? We've gotten so into the habit of just flipping the sign. But what is it about this? What can my denominator not be equal to? 0. So if I set this equal to 0, I'm going to come over here and demonstrate what we've been doing in our heads for a while. X minus 3 equals 0. How would I solve that for x? Add 3 on both sides. And I get x equals 3. That is how I'm getting that vertical asymptote. That is how I'm finding that h value. We just got so used to, like, every time we noticed our sign was flipping, and we're like, oh, I don't need to set it equal to 0 anymore. I can just take this shortcut. On this one, I'm not going to be able to take the shortcut, so we're going to have to take the long way around. So how can I figure out where this vertical asymptote is? Set it equal to 0. So I'm going to do 3x plus 5 equals 0. Minus 5 on both sides. So then I have 3x equals negative 5. divide by 3 on both sides, and that is my vertical asymptote. X equals negative 5 over 3. So whenever you can't look at it and just go, oh, I know what my h is, this is a opposite thing. If you can't look at it and figure that out, you can always take it and set it equal to 0. And it will give you your vertical asymptote. For the horizontal, we look at which piece, AH or K? K. What's my K value here? 0. So what's my horizontal asymptote? Y equals 0. Very nice work, especially for a Monday morning. I want to practice some more that are like number 2, and we're going to practice actually graphing them now. Friday we practiced factoring, figuring out what was canceling, finding our whole. We're going to put that all together. We're going to be on page 209. Very first thing I usually like to do is put my pluses and minuses around the corners. So I'm going to get my pluses and minuses on here. Is this in transformation form? No, so we're going to have to factor it. Whenever I have an x squared down in my denominator, I'm going to have to try factoring it first. Long division, I'm only going to use if I have just an x, not an x squared in my denominator. Will my numerator factor at all?
GCF.
GCF. What's the GCF up here? -4. Nice catch on the negative. Those of you that saw the 4, that is awesome. Remember, whenever your leading coefficient has a negative with it, we want to pull that negative out. All right, so y equals, we're going to pull that -4 out. What would I have remaining after I take a -4 out of each piece? X and then minus what? -2. Because remember, when I distribute, I want to get exactly what I started with. All right, now I'm going to go look at that denominator. Does the denominator have a GCF? No. Okay. So no GCF here. So I'm going to do my x. Will I be allowed to use the shortcut here?
Yes.
Oh, good. Multiply a times c. So what do I have up on top?
8.
8. Two numbers that multiply to 8, but add to what?
-6.
What multiplies to 8 but adds to -6?
-4, -2.
-4 and -2. So what will my denominator look like in factored form?
X minus 4, X minus 2.
X minus 4, X minus 2.
And you can guess who cancels out who.
I can cancel out what?
You can cancel out X minus 2.
I can cancel out the X minus 2. So there will be a whole where X minus 2 equals 0. I'm going to find the rest of that whole in just a second. I'm going to write down my transformation form first. Y equals, what do I have after I cancel out the X minus 2's? -4 over X minus 4. Let's find our whole. If there's a whole where X minus 2 equals 0, what's the X part of this ordered pair?
2 positive.
How did you get that?
X plus 2.
Yep.
Or just plus 2.
Plus 2 on both sides, yes.
Brain still is waking up slightly.
Absolutely fair. So the X part of the ordered pair is 2. How do I find the Y part of the ordered pair? Substitute. Y equals -4 over, we're going to put 2 in the place of X, and then -4. What is 2 minus 4? -2. So I have -4 over -2, which reduces to what? Close. Negative divided by negative gives me?
Positive
positive. So I have a positive 2 here. So that gives me the other part of this ordered pair. So my whole is at 2, 2. Can you tell me where the horizontal asymptote is going to be? Horizontal starts with what? Y. Horizontal back and forth has to go through our y-axis. So this is y equals, horizontal is always going to be a y equals k. So y equals what? 0. Where's my vertical? X equals 4. All right, so let's plot our vertical and horizontal next. Horizontal, y equals 0, so that's right here. Vertical, x equals 4, that's right here. What quadrants are we going to be in? Negative. How do we know? A is negative. So I'm going to circle my negatives. I'm going to scratch out my positives because I don't care. I only want the negatives. Before I use my A value to count, I'm going to graph my whole. So I'm going to go to 2, 2. Thank you, ma'am. So 2, 2 is right here. And I'm going to draw in a hole, like a big donut. And then I'm going to use my A value. A is negative 4. So how do I use that to graph the rest of this? Yep. Up 4. Up, down, left, and right 4. The negative part just means what? That it's going to be in the negative quadrant, so we're going to jump into the negatives. Other than that, I don't care about the negative. Up, down, left, right 4, and then in 1. So from where my asymptotes cross, right here, I'm going to go up. 1, 2, 3, 4, and I'm going to have to hop this way. So right here. Then I can go down. Always start where the asymptotes cross again. Down. 1, 2, 3, 4. And I'm going to have to hop to the right to stay out of the dead zone. So I've gone up and down. Now I need to go left and right. Let's go left first. 1, 2, 3, 4. And in 1. I have to go up or else I'm going to be in the dead zone. And then we're going to go to the right, starting from here. 1, 2, 3, 4, and in 1. This one's just like normal. Hug along the asymptotes, go through my points, don't cross the asymptotes. This one up here is almost exactly the same, except can you drive a car through a gigantic hole? Got to go around it. So when I get up to the hole, I can't go through it. You should not have a line going through the hole. It's going to come up here to the hole. It's going to stop. On the other side, it goes up to the hole and it stops. It does not go through the hole. They need to get a road crew out and patch it. But for now, we just have this big gaping hole here in our graph. So far, so good? Let's practice a couple more of these. I think after we get a little bit more practice under our belt, it'll feel more familiar. So we're going to factor, we're going to cancel, we're going to find our whole. We're going to put it in transformation form and graph it just like normal. I'm going to get my x equals and my y equals on there. I'm going to put a big open hole where we said the hole was. And then I'm going to graph it just like normal after that. Let's go look at number 2. Does the numerator have a GCF? No GCF. So can I factor the numerator? Nope. So I'm going to leave it be then. Y equals 2x plus 3. Does the denominator have a GCF? No. Nope. I'm not using long division because what did I see down in the denominator? I saw an x squared. Whenever you see an x squared, you need to factor. All right, so I'm going to do my x. Multiply a and c together. What am I multiplying together for a and c? 2 and 15. What is 2 times 15?
30.
I need two numbers that multiply to 30 but add to what?
13.
What multiplies to 30 but adds to 13? 10 and 3. 10 and 3. Both of them are positive. 15 and 2 would multiply, if you made one of them negative, you could get it to add to 13, but then it would multiply to negative 30. Can I use my shortcut here? No. Okay, so here's my two found numbers. I'm going to need to do an area model. So I have A and C, 2x squared and 15, 10x and 3x. What can I pull out across the top? 2x squared and 3x. What comes out of both? Just an x. What about 10x and 15? 5 goes into both. Positive or negative? This one's going to be positive. Why positive? Because the 10x is positive. So x plus 5 is one of the factors in my denominator. What about when I go vertically? 2x squared and 10x? 2x. 3x and 15? 3. Positive or negative 3? Positive. So 2x plus 3. Do you see anything that will cancel for us?
The whole numerator.
The whole numerator. Well, if I cancel the whole numerator, what's left in my numerator then?
1.
A 1. Down in the denominator, I have x plus 5 left over. Are there any x's left in the numerator here? No, not after I cancel that out. That is my transformation form. No x's in numerator. So that means I just write it down on this line. Y equals 1 over x plus 5. Do we know enough to put up our vertical and horizontal asymptotes?
Yeah.
So where would my horizontal asymptote be?
0,
Y equals 0. Let me get that put on there. Y equals 0 is right here on top of my x-axis. Where would my vertical asymptote be? X equals negative 5. So I come over to my graph, I go to negative 5. That's pretty far to the left on this graph. What do I still need to know? I need to know the whole. How will I find that whole? Yes. There is a whole where 2x plus 3 equals 0. Need a little bit more space. So if I wanted to find the coordinates of the whole, I need to solve this so that I can find the x part. What's the first thing I would need to do as I'm solving this? Minus 3 on both sides. So I get 2x equals negative 3.
And then divide by 2.
And then divide both sides by 2. What is negative 3 divided by 2?
Negative 1.5.
Negative 1.5. So that's going to be the x part of the ordered pair for the whole. Or if you really wanted to leave it as a fraction, you could. But remember, we're going to have to go and graph this. So I think decimal form might be the most helpful here. How do I find the y part? Substitute. We had y equals 1 over x plus 5, and x is negative 1.5 plus 5. Grab a calculator if you need to. What is negative 1.5 plus 5? 3.5. Can somebody grab a calculator and tell me what that is as a decimal? Because I want to go in and graph this thing, so I'm trying to figure out where this is on the graph. What is 1 over 3.5? 0.28. I don't care which way you write the ordered pair for the whole. I'm going to write the one that's in decimal form down here. Negative 1.5, comma, 0.28. Is 0.28 very big?
No.
Is it positive or negative? Positive. Okay, so I'm going to go to my x-axis. It says negative 1.5. That's in between what two numbers? In between negative 1 and negative 2. And then we have a positive number. So the whole is right here. Somewhere in between negative 1 and negative 2, above the x-axis. Have you guys ever seen when they show like weather maps or maps of accidents? I'm thinking specifically of the maps of accidents. They'll have like this big accident. And you're like, it's not actually taking up that much space on the road. But they're trying to show you its location. That's all I'm trying to do with this circle with the hole. I'm trying to show like, don't go here, there's a hole. Then we're going to use our a value. A is what? A is 1, so we're going to be in which quads? Positive quads. We're in the positives, not in the negatives. In the positive, not in the negative. So then we're going to go up, down, left and right 1, and always, always, always in 1. We're only going to have 2 dots. Where are they going to be?
1 in each quadrant.
1 in each of the open quadrants. It's going to be tucked into the corner right here on both of them because we're only going to move 1 unit and then in 1. So if I go to where the asymptotes cross and I go up 1 and then I jump in 1, it puts me here. Well, if I go to the right 1 and I jump in 1, I land on the exact same spot. My lower left quadrant, I'm going to graph just like normal. Hugs along the asymptotes, goes through my point. In that upper right quadrant, it's going to hug along my asymptote, go through that point, hit the hole. Does it go through the hole? Can't drive through the hole. From the other side, I can come up to the hole, but I can't go through it. Let's see if we can get one more done. Let's look at number 3. So we're on page 210. Does my numerator have a GCF? No GCF.
Okay, now I have a factor, right?
Will it factor?
Yeah.
I think it will. Will I be allowed to use my shortcut on this?
No.
Okay. So I'm going to multiply A and C together. What is A times C? Negative 84, you said? Okay. Interesting, you guys here. 3 times negative 28, you said, is negative 84. What's my B value? 5. What'd you say? We don't need them to go into each other. I want to know what multiplies to give me negative 84 but adds to 5. Here's one thing I know. When I see this, I know the two numbers that I'm looking for have to be pretty close together. If the number on bottom is bigger, the numbers are going to be farther apart. If the number on bottom is small, the numbers have to be closer together. Give me some things you know of that'll go into 84. 12 and 7. So if I did 12 and 7, is there any way to take 12 and 7 and add them together and get 5? Negative 7. B is positive, so the bigger number has to be positive. Ooh, bless you. On the bottom, yes it is. So at least that one factors nicely for us. 3x squared, negative 28. We have 12x and negative 7x. What can I pull out of the top? I can pull an x out. What about on the bottom? I know they're both even, so a 2 can come out of both of them, but is it the biggest? 4. Positive or negative 4? Positive, because my 12 is positive. What about vertically? 3x squared and 12x? 3x. Negative 7x and 28? Negative 7. So my numerator factors to be x plus 4 and 3x minus 7. And Soraya just said that the denominator there is a difference of 2 squares. So I know I'm going to have 2 factors here. What will the only difference be? One's positive, one's negative. What times what gives me x squared? X. So I need an x in both factors. What times itself gives me 16? 4. So I have a positive 4 and a negative 4, because when I times those together, I get negative 16. Do you see anything that will cancel? X plus 4s are going to cancel. So there is a hole where x plus 4 equals 0. I'm going to do that with a slightly smaller color here. So when I write down what I've got left over, I have 3x minus 7 over x minus 4. Let's find our whole. What's the x part of the ordered pair for my whole? Negative 4, because I'm going to subtract 4 from both sides. I get x equals negative 4. How do I find the y part of the ordered pair? Substitute. Y equals, I have to substitute in everywhere I see an x. So 3 times negative 4 minus 7, and down on the bottom 3 minus 4. What's 3 times negative 4? So I have negative 12 minus 7 over, what's 3 minus 4? Negative 1. I don't know where I got the 3 from. Let me fix that. That's a negative 4, right? Negative 8. Thank you for catching that for me, guys. I was like, that doesn't look right. So what's my numerator going to be? Negative 19, and down on the bottom I have negative 8. Negative divided by a negative is what? Positive. So we can write this as 19 over 8. Do you know where that is on the graph?
No.
Grab your calculators. Let's write it in decimal form. You said 2 point what? 37. Can you guys double check that for me? I don't have a calculator in front of me right now. I'm okay with you rounding it because I just want to see it on the graph. I need to see the ordered pair, but I want to see on the graph. So if you round it, that's okay. You said it's what?
It's
2.375. Thank you. Negative 4 and 2.375. Okay. I'll go ahead and write down everything that you had on your calculator screen. Is this transformation form? Can you identify AH and K from that?
No.
How do I get it into transformation form then?
Well, I don't know division.
Yep. We're going to use long division. So I'm going to have x minus 4 on the outside, 3x minus 7 underneath. What's my whole number that goes up on top?
3.
3. So here's K. I'm going to take that 3 and distribute it to both pieces. So 3x and negative 12.
Flip the signs.
Flip both signs. What do I have remaining? 5. There's my A value. Now I can write transformation form. Y equals what?
5 over x minus 4 plus 3.
5 over x minus 4 plus 3. Now I can identify my horizontal and my vertical. Where's my horizontal? Y equals 3. Vertical? X equals 4. Let's get this graphed and we're done. Put our pluses and minuses around the corners. We're going to graph those asymptotes. Y equals 3, so that would be a shift up 3. X equals 4, shift to the right 4. We're only going to be in which quads? Positives. Don't care about my negatives. I need to get the whole on here. Y is, or the x part of the order pair is at negative 4, and then 1, 2, it's about right here. It's going to be in between 2 and 3. Then we're going to use our A value of 5. So we're going to go up, down, left and right 5, and in 1. So from where they cross, 1, 2, 3, 4, 5, way up here in the corner. 1, 2, 3, 4, 5. This one's right on the edge of my graph. I'm going to go through those points. Try to curve along those asymptotes. 1, 2, 3, 4, 5, and in 1 puts me right here. And then down 1, 2, 3, 4, 5, and in 1. Hugs along the asymptote, can't go through the hole. skip over the whole. All right. Very, very, very nice work. Starting tomorrow, we're going to switch gears away from graphing, but I'm going to continue to have graphing as part of the bell work so that we continue to practice this. We have done all the graphing that we're going to do for this unit now. Homework 3 over asymptotes and removable discontinuities. That is due tomorrow. So that's the factoring, the canceling, finding the wholes. If it's not in transformation form after you cancel, if you still have an x up on top, then you would need to do long division. And tomorrow we'll switch gears and start solving.